Okay, we're back to quadratic equations and methods for solving a quadratic equation. And we'll go through this section over here. This section basically is a review of the past section. And, bottom line is, what does a quadratic equation look like and the methods for solving them. I got to be honest with you, my favorite technique is if I can factor these guys, which is called the zero product rule, I'm going to do that. But we have other methods, and I want to tell you what those methods are going to be. And certainly we're going to develop those over time. And then you're going to say which one works best for you. Well, I'm always going to try to factor. And then maybe if I can't do that, I might go into different techniques. And it's nice to have options. That's what we're trying to give you over here, options to solving a quadratic. And again, we'll go to the whiteboard later. But we'll go through those options. And then after we go through those options, we'll go through the examples, right? Don't be frightened by some things, though, today. For the most part, we're going to stick with simple concepts, really simple ones. And that is the past. We're going to stick with that. Again, we're going to slowly introduce new methods for solving quadratics. But right now, we're sticking with the past. All right. So let's take a look at the whiteboard. We can go new share. And we'll take it one step at a time. All right, let's talk about it. Okay, we're solving a quadratic equation. What's a quadratic equation? It's an equation at the mth100 level that's going to be in this form over here. It'll look like this. Oops, sorry about that. I need to cross that out. It's going to be this form over here. Okay, so the form is going to be, really very clear. A x squared plus bx plus c is equal to 0. Sometimes we're going to give you an equation that's not in that form, and then we're going to say, rewrite it in standard form. This is the standard form of a quadratic equation with the understanding that A, B, and C are constants, and the A is not 0. I want to tell you why we don't want the A to be 0. If A were 0, this term would disappear, and we would be left with a linear equation. Quadratics are going to be degree 2. All right. So I'm going to say, generally speaking, these are very easy to solve. Generally speaking, very easy to solve. And we have methods to do that. All right. I want to point out the biggest method we have is called factoring. Factoring is really what I refer to as zero product rule. So for example, if I were given this equation, I'll put it on the side for you. If I were given 2x squared plus x minus 6 equals 0, right? And I was asked to solve this one over here, I would definitely use the zero product rule. And what would I do? I'd say 2x and x, because 2x times x is 2x squared. Then I look at the 6. I'll be honest with you, there are options. It could be 2 and 3 or 6 and 1. Now, of course, if I say 2 and 3, which I like, by the way, I'm not saying it's right, I would not put the 2 here. Now, why is that? It would have been a GCF. So I put the 2 over here. Let's try that. And yes, you should be better at factoring. Now, what do I know? I know 2x times x, 2x squared. I know 3 times 2 is 6, but I really got to get the signs right and the middle term right. So I'm going to say plus 2 minus 3. I want to check and see if it works. What's 2x times x? 2x squared. It's called trial and error, by the way. Plus 4x minus 3x is plus x. That worked. And we do get minus 6. Then what do? We have the zero product. What's the rule? We set each factor equal to 0. We've done this in the past many times. And solve those simple linear equations. What does this give me? 2x equals 3. This gives me x equals minus 2. This would give me x equals 3 halves. Or, this is connected by an or, by the way, x equals minus 2. What would we recommend you do? We would recommend you check it. Where do you check it? Back in the original. All right. I'm going to say we've been doing this so often that I'm going to feel pretty good about that. And I just outline what we just did over here. We took this equation. We used the zero product rule, and we solved it. And we got the answers 3 halves or minus 2. All right. Same answer we did on side. All right, next one up is going to call the square root method. It's a nice method, but it's often misunderstood. Now, what does it say? We have a variable expression raised to a square, a 2, and equals some number k. If we can get our equation to look like this, we can solve them fairly quickly. And what do we say? The variable expression is equal to plus or minus the root of k. Let's look at this example over here. I'll write it down for you. And what's that example going to be? 2x minus 3 squared. That's a variable expression squared, just like this over here. And it equals the number 25. What am I going to do? Square root method. So the variable expression, 2x minus 3, would equal plus or minus the square root of 25. Well, that looks pretty simple. What do you get over there? 2x minus 3 equals plus or minus 5. I'm going to try to solve for x now. What do you get? Well, I get 2x. I'm going to add 3 to both sides. It's a lot of work, though. I know that. And then I'm going to divide both sides by 2. I got to be honest with you. That looks just awful to me. So I want to write it over here for you. What do you get? You get x equals 3 plus 5, which is 8 divided by 2, or you get x equals 3 minus 5, which is minus 2 over 2. And what do you get there? X is 4, or x is minus 1. We just did the square root method. I want to do it a little differently, though. I'm going to write it down for you again. It's 2x minus 3 squared equals 25. And I want to go back to your past, what you did in the past. Well, in the past, you would have used the zero product rule. Let's continue to do that. So I got to simplify the sides. I'll write this down for you. And what do you get there? Well, you get 4x squared minus 6x plus 9 equals 25. 4x squared minus 12x plus 9 equals 25. I would subtract 25 from both sides. And again, this is our common past. We've done this many times before. Let's see, that would be what? Minus 16, right? Then what you've done, well, I got my 0. I got to get a product now. And what I would do, I'd probably factor out a 4 in this guy over here. All right, so 4 comes out. And what are you left off with? X squared minus 3x minus 4 equals 0. That's not so bad, right? Let's keep going. 4. It's a lot of work, though. I realize that. We're trying to encourage that, by the way. Work. Minus plus. Does that work? You get x squared. Well, minus 4 plus 1 is minus 3x. That worked. You should get minus 4. So what are the answers over here? Well, 4 never is 0, but x plus 1 becomes 0 when x equals minus 1. And x minus 4 becomes 0 when x equals 4. All right, let me just go back and make sure you know we got the same answers using the square root rule right over here. Again, someone says, which one method am I going to use? You don't know what you like until you try it. Try these methods, all right? I like the zero product rule, all right? I just did that, all right? Let's take a look. This guy over here, and it's like the a formula, all right? So let's read this formula to you then. And formulas are nice to have because they make problems really easy to deal with. This is called the quadratic formula. It says if we have an equation of this form over here, where a, b, and c are constants and a does not equal 0, we can write the answer down immediately. I mean immediately. Write down immediately. All it requires is knowledge of an A, a B, and a C. And then you got to do the arithmetic. The problem with this formula, though, for most students is actually simplifying it. All right. It's easy to write it down, but simplifying it gets very, very difficult. All right. Let's go to the next page. And we'll look at an example, okay? And we'll go through it. So I'm going to take this example here, and I'll just summarize what we need to know about this. I don't think I did that right. You know what? I didn't do that right either. Blow it up a little bit. Let me get rid of this thing over here. So over here. And I'm going to go through the quadratic formula. And before I do that, I want to point out a quadratic formula is as follows. We need an equation of this form over here. A x squared plus bx plus c is equal to 0. So I can, initially just simply say, oh, it's in the proper form. It's equal 0, and I can identify the a. And I would highly recommend that you should identify a, b, and c. What's a? 3. What's the b? It's 2. What's the c? No, we're not trying to trick you. It's actually -8. Now, why is that? These are written as addition problems. So it's going to be plus -8. Okay. Then what do I put down? The quadratic formula. What's quadratic formula say? Well, it says x, which is the variable, is equal to, and I'll write this down very carefully. It's a long fraction bar. The opposite of b, we'll do this later, plus or minus, let's see, b squared minus 4 times a times c. What goes on bottom? Twice a. Well, I'm going to write this down. Like I said, the worst thing for students to do now is simplification. But let's be very careful about this. What's twice a? This is not memorization. This is reading. Twice a is 6. Twice a is 6. I'll write this down for you. All right, let's keep going. What do I put here? The opposite of b. Well, what's the opposite of b? -2. Okay. This is where a lot of students really screw up. It's the radicand. And I'll point it out to you. It's the b squared. Well, if this is the b, what would b squared be? 4. Minus, here comes the tough part, 4 times a is 3, and what's c? -8. All right, so at least I wrote it down. Now my question is, can I do the arithmetic or simplification? I think so. I'm going to look at it. And again, if you use a calculator to do it, that's fine, but I think probably it would be hurtful if you did use a calculator and you got it wrong. And I'm going to just talk about it. And I realize it's 4 times 3, which is 12. And then 12 times -8, that's going to be -96. And minus of -96 is plus 96. And 4 plus 96 is 100. All right. A lot of students struggle with that. They make mistakes. Even with the calculator, they make mistakes. And that's what you have to struggle with, getting it right. Now, granted, I didn't make a mistake. I'm just saying that a lot of students make mistakes. So I got to do the arithmetic now. What do you get? 6 minus 2 plus or minus. What's square root of 100 is 10. Let me keep going. I'll write down what I'm seeing over here. X equals -2 plus 10 over 6, or x equals -2 minus 10 over 6. And again, I want to point out, this is a nightmare for most students. It's all the work in the arithmetic. What's -2 plus 10? 8 over 6, or x equals, this would be -12 over 6, right? Well, I'm still not done. What do you get? X equals, what's 8 over 6? 4/3, or x equals -2. I got my answer. We just used quadratic formula. First time I used it, by the way, or at least in class, first time I used it. And you might have used this in your prior course. I really don't like it. All right, it's just so much work. I think you see all that work. What I want to do is I want to try to use the 0 product rule on this over here. So let's write this down. So 3x squared plus 2x minus 8 equals 0. Well, I got the 0, but I don't have a product. Well, this is pretty simple because there's only one choice in my, finger number world, 3x times x. I got to do that 8 now. I'm going to say, let's see, it could be like 2 and 4, 8 and 1. Not much choice in that. I'm going to say 4 and 2. I'm not saying it's right, by the way. Really plus minus here. Let's see if that works. 3x times x, 3x squared. 3x times 2 is 6x, minus 4x is 2x, and I do get the minus 8. So I think I'm ready to write the answers down now. What's the answer going to be? When does 3x minus 4 equal 0? Or when does x plus 2 equal 0? Well, the second equation equals 0 when x equals minus 2, and the first one becomes 0 when x is equal to 4/3. Okay, zero product rule is super simple if you can factor. The quadratic formula was a lot of work for me, but does it lead to the same answer? Let's take a look. You can see the amount of work difference though, right? Look at all the work over here. Work, work, work. The work over here is really simple. Do we get the same answer? Of course we do. 4/3 or minus 2. Let's go back to the key. And we see in the key 4/3 or minus 2. Again, we have to go through this method. What's the method we have to go through? Well, not so much quadratic formula, we're really not there yet. What do we need to do? Review standard form, factoring or zero product rule, and the square root rule. We'll get to the quadratic formula eventually. It is nice. And when's it nice? When I can't factor. That's when it's nice. All right. Thank you.